Hello viewers, in today's session we are going to discuss some important problems from application of derivatives. So here the problems are related to some important inequalities, and here with the help of the concept of increasing and decreasing functions will prove these two important inequalities. In the first problem we have cos x is less than x plus 1, and in the second problem we have cosine of cos x is greater than sin x for all values of x belonging to the open interval, that is 0 to pi by 2. So here x varies from 0 to pi by 2. So we'll see how we can prove these inequalities easily with the help of the concept of increasing and decreasing functions. So let us start. So to begin with, we'll take the function f of x is equal to x minus cos of x, and x belongs to the interval 0 to pi by 2, right? So here we'll see that this function f of x is an increasing function, and to prove that this function is an increasing function, we'll first find out the derivative of this function, that is f prime of x is equal to 1. That is, the derivative of x is 1, then the derivative of cosine x is minus sine x. So we have 1 plus sine x. So the derivative of f of x is 1 plus sine x. And see, this function, that is sine x, is greater than 0, or it is positive in the first quadrant, that is when x belongs to this interval, that is 0 to pi by 2. So obviously 1 plus sine x is also greater than 0, or 1 plus sine x is positive when x belongs to this interval, right? So what we have seen here, the derivative is 1 plus sine x. Now sine x is positive, or it is greater than 0 in this interval, that is the first quadrant, and therefore this quantity, that is 1 plus sine x, because 1 is positive, so when we add two positive quantities we always get the third quantity as positive. So 1 plus sine x is also positive, so this quantity is greater than 0. So we can see f prime of x is greater than 0. So the derivative is positive, and this is the condition for a function to be increasing function. So when the derivative is greater than 0 or positive, then the function f of x is said to be an increasing function, right? So here let us quickly see the another definition of increasing function. Here we have the axis, and let us take an increasing function, say y is equal to f of x, right? And let us take 2 points x1 and x2 on this curve. So we have here x1 and this is x2. So this point A has coordinates x1 comma f of x1, right? And this point B has coordinates x2 comma f of x2. Now we can see that when x1 or x2 is greater than x1, because here x2 is greater than x1 and the function is an increasing function, then this ordinate, that is f of x2, is also greater than f of x1. So this is an important concept in increasing and decreasing functions, right? So when x2 is greater than x1, then f of x2 is also greater than f of x1 when the function is an increasing function. So we can write this expression as x1 is less than x2 implies f of x1 is less than f of x2, right? And here we have this inequality, that is x greater than 0 and less than pi by 2. So let us take x1 as 0 and x2 as x, right? So we have f of 0 is less than f of x. So let us find f of 0 from this expression. So f of 0 is 0 minus cos of 0. So this is 0 minus 1. Cosine 0 is 1. So we have minus 1, right? So here we have minus 1, and here for f of x we can write x minus cos x. So now we can take cosine x to the left hand side and minus 1 to the right hand side. So we have cos of x is less than x plus 1 when x belongs to this interval, right? So this is our desired inequality. Now let us prove the second one. So now to prove this inequality, let us take x1 as x and x2 as pi by 2. So we can now write f of x is less than f of pi by 2. Now let us find out f of pi by 2 from this function. So we have f of pi by 2 is pi by 2 minus cos of pi by 2, and cos pi by 2 is 0. So we have pi by 2 minus 0, that is pi by 2. So we can now write f of x is less than pi by 2. Now f of x can be replaced by x minus cos of x, and here we have less than pi by 2. So let us rearrange the terms. So we can now write minus cos x, and we can take this x to the right hand side. We have pi by 2 minus x. So now we have this important inequality. So now let us take the cosine of both these sides. So we have cos minus cos of x, and here we have cos of pi by 2 minus x, and here the direction of the inequality get reversed, because the cosine function, that is cos of x, is decreasing function in the interval that is 0 to pi by 2, because when we find the derivative of cosine x, then the derivative is equal to negative sine x, and sine x is positive, so minus sine x is less than 0 in this interval. So the derivative of cosine x is negative in the interval 0 to pi by 2, hence cosine function is a decreasing function, right? So here when we take cosine of both sides, the direction of the inequality get reversed. So here a cos of minus cos of x. So here we can make use of an identity from trigonometry, that is cos of minus theta is equal to cos of theta. So here we have simply cos of x, and here cos 90 minus theta, that is cos of pi by 2 minus theta, is equal to sine theta. So here we can write sine x. So cos of x is greater than sine x in this interval. So this is how we can prove this second inequality.